All right, here we are. We're going to do a quick lesson about balancing chemical equations because I know that a lot of you guys are struggling with that. So I'm just going to go over a few examples that are pretty straightforward, but hopefully will teach you some of the basics that will help you balance simple chemical equations. So they're really not that bad once you get the hang of it. The first thing and the most important thing that you need to remember when you're balancing chemical equations is the idea of the law of conservation of matter, or sometimes it's called the law of conservation of mass. Both are fine. And so this is this notion that matter cannot be created or destroyed, right? And so that means, as far as chemical equations are concerned, that you have to have the same number of atoms for each type of element on both sides of your equation, right? So on your reactants and on your products side. Wow, this is not legible. The way that we do that is not by adding new substances to our chemical equation. We simply change the coefficients. And if you'll remember, a coefficient is the large number that is in front of your molecule or your compound or your atom that you're talking about, right? So here in this 2H2O that I drew, the large number in front of the H, the 2, is our coefficient, right? And you'll remember also that this small number down here is not a coefficient. It is, in fact, a subscript. And maybe you're remembering words that start with sub, like submarine, as a word that describes something that's kind of goes down or is low, right? And so sub means below. So the subscript is that small number that's down on the bottom, okay? Coefficient is the one that's right next to your atom or your molecule or your compound. Okay, so let's do a few examples to practice, and hopefully that clarifies a little bit. So starting out with a simple equation I have ready to go right here. So we have a reaction where carbon monoxide, so CO, is turning into carbon and carbon dioxide, right? So when I see an equation like this, the first thing I like to do is first remind myself that this is the reactants, and these are my products, right? Wow, that is not legible at all. Anyways, so your reactants, again, are what you're starting with. Your products are what you're ending with. And I like to go through and just identify what are the different elements that I have on each side. And they should be the same, but just to make sure, right? So I know that I have right here a carbon, and I also can see that I have an oxygen. Oh, okay, so I draw it like that. And I make myself a nice little table. Oh, wow, that's not good. Let's try that one more time. Let's go line. Yeah. And if for whatever reason you don't have enough space, never be shy to take another piece of paper and rewrite your equation and give yourself plenty of space. It's not worth it trying to squeeze your work onto a small piece of paper and then get something wrong because your handwriting's messy or because you don't have enough space. Always give yourself enough space to do your work. So back to the equation, we have our product side, right? And again, we have a carbon, right? We actually have two carbons, but the element that I have on that side is carbon. And then I also have an oxygen. So that's good. So I have carbon and oxygen. That's what I was hoping for. So let's take inventory. And what that means is count up the number of each type of atom that we have. So in our reactants, we have how many carbons? 1, correct. How many oxygens? Also 1, okay? So that's how many I have so far. And in my product side, how many carbons do I have? 2, right? Because I have 1 here and I have 1 here. And how many oxygens? If you said 1, or if you're thinking 1, don't let the subscript trick you, right? So this little 2 down here is telling me that I have 2 of whatever is right in front of it, right? So I have 2 oxygen atoms there. Maybe it would be helpful if I drew for you what each of these substances looks like, right? So carbon, CO2 is a carbon that's attached to an oxygen that's attached to another oxygen, right? So we have oxygen. This is not easy to do. You know what? I'm just not going to circle it. I think that's not a good idea, right? So I have carbon, and I have oxygen, and I have an oxygen, right? Here, I just have carbon, and here I have a carbon that's actually attached with a triple bond to an oxygen, right? I hope that that's clear. I know that my drawing skills are subpar here. Anyways, going back to the oxygen, I have 1, 2 oxygen atoms over here. So you take an inventory of it and you notice, are they balanced? No. My goal, though, is for me to have the same number of carbon atoms and the same number of oxygen atoms in my product side and in my reactant side. So what do? Let's start with the carbons. It's always a good idea to start with the metals. So the first one I'm looking at is my metals. Sorry, not metals. Carbon is a non-metal. Never mind. Start with carbon. You can start with metals, but we don't have any metals, so we're going to start with carbon. Okay, so we need to balance the carbon. So what we can do here is we can change the coefficient into a 2, right? And so what that 2 means is that we're multiplying that 2 by this whole molecule, by the carbon and by the oxygen, right? What that would mean in terms of my drawing, if I decide to do a drawing here, that would mean that I have 2 of these carbon monoxide molecules. So now we can recount how many we have, right? So how many carbons do we have? 2 in our reactant side. And how many oxygen atoms do we have in our reactant side? Also 2, right? And lo and behold, that was pretty straightforward. Are we balanced here? Let's check. Let's just go over it one more time to make sure. So on our product side, we have 1, 2 carbons, yay. And in our for our oxygen atoms, we have our 2 oxygen atoms, yay. Okay, and now if we go back over here, if we have this as our coefficient, this 2, then we have 2 carbons, yay, and we have our 2 oxygens, okay? So that one is pretty straightforward. I apologize for a mistake about the metals. Hopefully my next example will be better. So let's try another one that's slightly more complicated, or maybe a little bit more complicated. So the next one I wanted to look at is the reaction between nitrogen and hydrogen to make ammonia, or NH3. And I think I'm going to draw you the molecules here to make it a little bit clearer. So for nitrogen, notice that we have this 2 here, right? Our subscript is 2. So we have N. And maybe you're thinking, why are you drawing 3 lines and not 1 line? And that's because there are 3 bonds between each of those atoms. And you don't need to know that now, but I'm drawing it just so that you have it there. But the point is that you have this N2 molecule. Over here, we have hydrogen, and it's connected to another hydrogen, right? So we have 2 hydrogen molecules. And then in our product side, we have nitrogen, and it's attached to hydrogen, to another hydrogen, and to another hydrogen. Okay, so we have 1 nitrogen and our 3 hydrogens, right? So again, I'm going to circle these subscripts to remind you so that they don't throw you off. And I'm going to remind you that this side is our product side. And over here we have our reactants. Yay. So let's take inventory. Let's count up what types of elements we have on each side. So on our reactant side, we have nitrogen, N, and we also have hydrogen, in our product side, no surprise, we have nitrogen and we have hydrogen. When you make these tables, it is my recommendation that you keep the elements that you have in the same order, right? So I have nitrogen written and then hydrogen. I would not recommend writing hydrogen and then nitrogen because you're going to confuse yourself when you're comparing the numbers. Or if I do that, I confuse myself. Maybe you won't. Anyways, so let's count them up. So how many nitrogen atoms do we have? Or yeah, how many nitrogen atoms do we have on our reactant side? 1, 2, right? How many hydrogen atoms? 1, 2. That's great. And in our products, how many nitrogen atoms do we have? 1. And hydrogens, we have 3. Okay, so we have some work to do. I would recommend starting with the nitrogens. So if we want to balance out the nitrogens, what do I need to do to my coefficients? Well, I have 2 here, and I have 1 here, so I have to add more here. So start out by adding a 2. You might be tempted to try other numbers. I recommend that you start with lower numbers before you go to higher numbers because sometimes you'll take yourself down a road and then realize that you need to backtrack and it's kind of confusing. So just take baby steps, right? So let's start with 2. And now that's all great because we have 2 nitrogens, right? And we have 2 nitrogens on this side. So that's good. But the question is, how many hydrogens do we have here? So remember, when I put this coefficient 2 in front of my molecule, that means I don't have 1 of these molecules. It means that I have 2 of them, right? So I have nitrogen attached to hydrogen, attached to hydrogen, attached to hydrogen, right? And I have that 1, 2 times, okay? So that's what that 2 means. So when you're doing this, you don't need to draw it out, right? You might be able to imagine this without drawing it out, and as you practice it, you will be able to do that. But we can count up how many hydrogens we have, and we see that we have 6. But you could also figure that out if you realize that this 2 is multiplying by however many hydrogens you have, right? And if we have 3, then we're multiplying 2 times 3, and that gives us a total of 6 hydrogen atoms. Okay, so whichever way makes sense to you, I recommend starting out by drawing things if you can, and then going to the kind of more advanced version of multiplying, but if you feel comfortable with that, then go for it. Okay, so we have 2 nitrogens and 2 times 3 hydrogens, so that's 6 hydrogens. So now we still have some work to do here. So our nitrogens are balanced, right? But now we have to move on to our hydrogens. So here we have hydrogen, but remember it's diatomic, right? It has 2 hydrogen atoms in each molecule. And so we have to think, what number could we multiply it by? And maybe with a little bit of mental math, you'll realize, aha, I need 3 of these, because if I have 3 times 2, that will give me 6 hydrogens. And again, I can draw that out for you so you can see it, right? So if this is 1 hydrogen molecule, here's another hydrogen molecule, and here's another hydrogen molecule, right? And that gives me 1, 2, 3, 4, 5, 6 hydrogen atoms, okay? And so let's count everything up on this side now. So we still have our 2 hydrogens like we did, or 2 nitrogens like we did before, but now we also have our 2 times 3 hydrogens, so that gives us 6, right? And it's always a good idea to check, double check, because sometimes you'll make a mistake in your math, or you'll forget about a molecule. So again, we have 2 nitrogens, 6 hydrogens, 2 nitrogens, 6 hydrogens. Good, 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 good. Okay, so now we have our balanced equation. So it would be N2 plus 3H2 yields 2 NH3, also known as ammonia. Okay, let's do one more example, and then maybe I'll try also a challenge example with you guys. Here we have, oh wait, no, I didn't switch slides. Here we have, finally, a reaction with metal, yay. Although you could argue that hydrogen is a metal, I guess. Anyways, so we have a reaction between iron and chlorine to make iron chloride, okay? So we have our reactants, and we have our products. So I'm going to circle the subscripts just because I don't want you to forget them. And I'll draw out your molecules again. As always, I really recommend that you take your time with these. Nobody wins anything by doing these super fast when they're still trying to learn them. Should you do them fast on a test when you should have mastered the skills? Absolutely. But while you're learning, there is no rush. Give yourself the time you need to learn this. So when we have, so we have Fe, which is iron, just to remind you guys, and then we have chlorine that's attached to it, and we have 3 chlorine atoms for every iron in our products. And here, remember, chlorine is diatomic. It has 2 atoms for every molecule. So we have 2 of them there. So let's take inventory. Let's count up what we have. We have an iron, great. We have a chlorine, yay. Over here, we have iron, whoop-de-doo, and we have chlorine. Fabulous. Let's start with our reactants. How many chlorine atoms do we have here? Yep. And how many, did I say chlorine? I meant iron. Iron. It is late for me. I'm just going to put that out there. Iron atoms. How many chlorine atoms do we have? We have 1, 2. Great. In our products, we have how many iron atoms? Just 1. And then how many chlorines atoms we have are 3. Yay. So this is pretty cool. Right now, our metals are balanced, but don't get too attached to that. Sometimes you will end up changing one of the species, one of the types of substances you have in your equation, and it's going to throw off your balance for everything, but that's okay, right? So we're going to start by balancing our chlorines, but maybe after we balance the chlorine, we'll realize we have to go back and we have to balance the iron, and that's okay. Okay, don't be scared of doing that. So I have 3 chlorine atoms here, and I have 2 chlorine atoms over here. What can I do? Well, I could put a 2 here. I could multiply this by 2. But maybe you'll realize that if I multiply this by 2, that will give me 4, and that won't be the right ratio here, because this is a ratio of 2 chlorine atoms and 3 chlorine atoms on this side. So we could multiply it by 2, but I recommend multiplying it by 3. Right. So if we multiply this by 3, that will give us how many chlorine atoms? I hope you said 6, right? And I can draw that for you. So we have chlorine and a chlorine, and then we have another one, chlorine and a chlorine. Okay? So that gave us a lot more chlorine atoms than we may think that we need, but what you'll remember is that you have this one that is in a ratio of that has 2 chlorine atoms. And so if I take my molecule that I have over here, and if I multiply it by 2, that's going to end up giving me the same ratio of 2 and 3 and 2 and 3, right? So it's sort of like a inversion. So I recommend that you try to look for patterns. You can do it step by step, but once you get better at this, you might be able to see some patterns that will give you some shortcuts here. So in our reactant side, we still have our 6 chlorines and our 1 iron. But now in our products, when we multiply this by 2, we see that we have 2 irons and we have 2 times 3 chlorine atoms, which gives us 6 again. Okay? And I can draw this out for you one more time just to help you see what we're doing here when we have that coefficient. I know that it's a little bit slow, but, well, I don't know if it helps with my really bad drawings. Okay, so like I said before, sometimes you're going to start balancing and something was balanced and it's going to get unbalanced because you balanced something else, and that's okay. That happens sometimes. But here, even though I have more iron, that's not a big deal because it's really easy to just balance the iron in my reactant side, right? So I have my 6 chlorines, and that's good. But I have 2 irons, right, in my product side. So if I go back to my reactants, all I have to do is multiply this by 2. Ding! And now I have achieved that balance that I wanted. Because I have 2 iron atoms, and I have 6 chlorine atoms, right? 2, 6, 2, 6. Okay? So let me just draw that second iron so you see it here. So that's kind of how you balance chemical equations. I'm not really sure how long this has gone on for, but we could balance one more that's a little bit harder to do, but I didn't prepare a slide to do that. Let me see. Let me do this. So sometimes you're going to have chemical reactions where you have a combustion reaction with a hydrocarbon. So what that means is that you have something that is just carbon and hydrogen, and it's going to react with oxygen, and your products are always going to be, if it's a complete combustion, CO2 and H2O, carbon dioxide and water, right? And this is a simple one, but I think in your homework you had a little bit more complicated one, and in these types of reactions you will end up with oftentimes quite a bit of oxygen that's reacting. This one doesn't have that much, but there's one problem where you might have 7 molecules of oxygen reacting. And here's my quick kind of like end of this video recommendation. When you do these kinds of equations, I recommend that you start with the carbon, then you balance the hydrogen, and you do the oxygen last. In combustion reactions, it's a good idea to do the oxygen last because you have a lot of it, and it can be kind of frustrating when you try to balance the oxygen early on, right? So here in our reaction we have carbon, we have hydrogen, and we have oxygen. And here we have carbon, we have hydrogen, and we have oxygen, right? And if we count up the number of carbons we have 1 on this side, we have 1 on this side, 2 hydrogens, right? And we have 3 oxygens. And on this side, we have 4 hydrogens and we have 2 oxygens. So immediately I can see that my carbons are balanced. So I'm going to go to the hydrogens, right? And I will multiply that one by 2. So then I still have my 1 carbon. I have 4 hydrogens now because it's 2 times 4. And now I don't have 3 oxygens, but I have 2 and then 2, right? And so that gives me 4. Okay? So when I go to this side, my carbons are balanced, my hydrogens are balanced, and now I just have to balance out my oxygens. And it's easy to do that because I have 4 here. As long as your oxygen number in your product is an even number, so 2, 4, 6, 8, 10, 12, etc., then you can easily balance it on this side, right? So I just know that I need a 2 here, and now I have my 4 oxygens, because it's 2 times 2, and I have 1 carbon, and I have my 4 hydrogens. And now I know that I'm balanced, okay? So again, I know that was really quick, and we can talk about it more, but in general, when you have reactions like this, where you have a hydrocarbon, where it's just carbon and hydrogen, and it's reacting with an oxygen molecule, and forming carbon dioxide and water, try to balance your carbons and your hydrogens first, and make sure that your oxygen in your product side is an even number, and then just go back and you'll balance out your oxygens in your reactant side. Okay, so that was a really quick explanation of balancing chemical equations. I hope that helps. Let me know if you have any questions, and have a good day.